So finally, to conclude our section on eliminations, we have our second in-class exercise. And this is where I would remind you, if you haven't started working on these problems, pause the video for a little while and then come back when you've tried these. So one of the things that can be helpful in these problems is to start by identifying whether we're looking at E1 or E2 in each case. And that's relatively straightforward. In the first three, we have protic solvents, methanol and water. So that means those three are all going to be examples, potentially, of E1. In part D, we have DMSO, which is an aprotic solvent, and so we're looking at E2. Alright, so what happens here? Well, in an E1, we know that it starts with the leaving group leaving, and then the base methoxide removes an adjacent hydrogen to form the alkene. So, is it necessary to draw a mechanism for every single reaction that you do? No, but it can be very, very helpful. Part B, which we've also identified as an E1, same sequence, leaving group leaves, forms a slightly less stable secondary carbocation, but that secondary cation is next to an alkene, it's resonance stabilized, we don't have any issues to worry about. Now, where will we remove a hydrogen from? Will we remove this red one or the gray one? So, actually it has to be the gray one, and we can see that if we draw both products here. So that's the product we form if we remove the gray hydrogen. If we remove the red hydrogen, we would get that product. And if we tried to form that product, that would mean this carbon that I've highlighted here in blue would have to be sp hybridized. And if you recall, sp hybridization means linear geometry. And there's just physically no way that we can have linear geometry within a ring as small as 6 carbons. So that tells us that this is the only possible product that can form here. Alright, part C, again, our leaving group leaves. Giving us the very stable tertiary carbocation, which our base can then remove an adjacent hydrogen from. And finally, part D is an E2 elimination because of the aprotic solvent. Yes, the leaving group is tertiary, but hopefully you recall at this point that we said that tertiary leaving groups are fine for E2 because the base is actually reacting not where the leaving group is, but on an adjacent carbon, and we get our elimination to take place. Finally, in number 2, I've given you 2 possible eliminations that you could use to make styrene. And I'm telling you based on the question that one of these methods is going to be better than the other. And I want you to try and identify which one that is. Easiest thing to do here is to draw out your mechanisms. So given the protic solvent of ethanol, we know the first step would be the leaving group leaving. Just going to abbreviate our aromatic ring here with pH. And that gives us a primary carbocation. And we know that's probably not a very good pathway. In the second example, we get a secondary cation, which is also resonance stabilized by the aromatic ring. So there's pretty little question as to which one would be better here. Both of them, if they worked, would give us the correct product, because we'd remove this hydrogen in the first case to get styrene, and we'd remove a hydrogen from this carbon to get styrene. But we can also see very clearly there's a huge difference in the stability of the cation. The molecule on the left gives us a primary cation versus a highly stabilized, both secondary and resonance stabilized cation on the right. That tells us that due to the stabilization of the intermediate, it'll be much easier to form the carbocation in the reaction on the right, and that's going to be the much better pathway to form styrene. So again, as just another reminder, these practice problems are intended as a good starting point for you as you work through eliminations. But at this point, you should start looking at more practice problems. And those could be some of the old exams I've posted on Blackboard. It could be your assigned homework problems, or that could be additional practice problems, say from the back of the chapter in your textbook. You want to keep working through as many of these practice problems as you can. It's by practicing these mechanisms and these reactions that will really help you to understand them.